temperature, there are exothermic reactions and endothermic reaction. We can notice the reaction by the enthalpy value. The negative enthalpy indicate exothermic and the enthalpy value with the positive number indicate endothermic. Since exothermic release the heat during the reaction, the position for the heat will be at the product, and since the endothermic use the heat during a reaction, the position for the heat will be one of the reactant. And the temperature is one of the changes that can change the equilibrium constant. The negative enthalpy value shows that this reaction undergo as exothermic. The position for the heat will be as a product. As the temperature of the system being increased, the equilibrium position will shift to the left. As a result, the concentration for the reactant will be increased and Kc decrease. When the temperature of the system being decreased, the equilibrium position will shift to the right. As a result, the concentration for the product will be higher, as well as the Kc. A positive enthalpy value shows that this reaction undergo as endothermic. The position of the heat will be as a reactant. If the temperature of the system being increased, the equilibrium position will shift to the right. This makes the concentrations of the product to be increased as well as the Kc. If the temperature of the system being decreased, the equilibrium position will shift to the left. This makes the concentration of the reactant to be increased and the Kc decrease. Addition of inert gas can happen at two situations, either at constant pressure or constant volume. By adding inert gas at constant pressure, the partial pressures of the reacting gases will be decreased, as well as the volume of the mixture keep on increase. In order to offset the stress, the system responds to increase number of gas molecules until Q is equal to K. As a result, the equilibrium position will shift to side with a greater moles of gas. By adding inert gas at constant volume, there will be no effect on equilibrium position because the partial pressures for the reacting gases remain unchanged. Additions of catalysts to a system will speed up the reactions by providing alternative pathway and lower the activation energy. This will increase the forward and reverse rate to the same extent. The time taken will be shortened to reach equilibrium. But the catalyst has no effect on the equilibrium position as well as for the Kc. These are the energy profile diagram for uncatalyzed system. Just after the catalyst being added to a system, we can see that the activation energy for the system become lower for both forward and reverse reaction. This shows that the time taken for the reaction to forming a product become faster. but it will not affect the equilibrium position.